Okay, setting up the Rangate 15 to 30 adjustable groover, and this time we're going to set it using the distometer to aid in our setup. So it's normally a good idea to have a couple spacers on your spindle, not particular any thickness, but just one or two spacers at the bottom. Also a good idea to wear gloves when handling these sharp cutters. They're razor sharp, some of these inserts. Placing the cutter in the machine, making sure it's clean with no sawdust on the spacers. Spacing rings on, also paying particular attention that everything is clean. Always check to make sure the cutter is secured and no spinning. Alright, so this time we're going to put a groove in the center of this 45 millimeter thick workpiece. So we're going to put in a 16 millimeter wide groove at a depth of 15. So we can either measure with the distometer to the top or the bottom of the cutter, and we always measure to these cutting spurs because that's where the action is. That's be the outside edge of the cut. So according to the calculations of the thickness of the wood and the 16 millimeter width of cut, we want 14.5 millimeters from the bottom of the workpiece to the start of the groove. So I'm simply going to use a distometer, find my bottom spur. I'll just manually take the spindle down. Okay, got it, 14.5. Now for the depth. The depth is a little tricky. I'm going to lock the fence down, again using the distometer. We'll measure to the cutting circle, and you kind of got to rotate it a little bit just to get it exactly where you want it. Just move the fence back till we get to 15. Pretty close right there, so I'm going to lock it down. Trying to check it. So we're pretty close now with this distometer. Sometimes if you're trying to be real exact, you still have to come back and maybe fine tune a little bit. So at this point we'll close the fence halves. Tighten them down, avoid the Eigner bridging. Now at this point I probably need to make a test cut just to make sure everything is good. So we'll do a test cut just manually. Making test cuts, it's a good idea to use the overhead guard. We're not using the power feeder. Once again, we want to make sure that the feeder is clear. Just get the visual. So I'm just going to run this in slightly and then check my cut. 0.3 millimeter. We need to be at 14.5. Depth is perfect at 15. That's exactly what we wanted. So we're going to drop the spindle 0.3 millimeters. We should be good this time. Let's see where we are now. .5, that's perfect. Okay, I want to show running a small piece without the power feeder. We normally always use the power feeder, it's just safety, but you know, there's times that you need to run things manually. So I'm going to show the safe way to cut this groove on a small, narrow piece manually. So we'll employ the bridging once again. Always testing the cutter to make sure we're clear. And we'll use the overhead guard. I'll have to do a little setup on that. We're pushing in both directions here, which is nice. So we're going to use the outside to push, give a little pressure against the piece. That's plenty right there. And then the inside piece is pushing down, as you can see. Not too much pressure, just enough to hold it. It's actually just perfect right there. This also serves, the cutter is totally shielded. So what I'm going to do is push this through, and I'm going to use this push stick, especially since this is a short piece. We're ready to go. Let's check that one more time. So that's a safe and accurate way to run the piece manually. I might add, with these adjustable groovers, you get a very clean cut along the edge, and that's all because of the the little scribing knife. So even in a wood that's pretty marginal like this knotty alder, it's still get a really clean edge on the cut. Now we're going to take the same groover that we used to do the groove, and we can turn this into a tool to do a stub tenon simply by flipping the cutters around and stacking spacers between them. I'll go like that. So with this particular cutter, the tenon thickness will be the desired tenon thickness -3. You can see the little 3. You know, so we've got to take into account that 3 millimeters. Okay, we'll start by stacking the cutters carefully on the spindle, making sure we're clean, using the gloves. The bottom cutter in. Spacers. Top cutter. I normally offset the cutters like that instead of going like that. Just put them together like that. apply our other spacers. Keep them clean once again. Check, make sure you're not secured. I'm going to use the Agner device to cut the stuffed tenon. This could also be done with a sliding table. We're going to bridge the cutter carefully. Makes it a very safe cut. We're pretty close to the bridging there, so we just want to really rotate that to make sure everything clears. All good. Under the hood. So now we're going to be using this device as a guide. The beauty of this is the workpiece is resting on the table surface, so it gives us a nice firm calibration. I'm also going to employ the overhead guard on this just for a little added safety. We'll insert the workpiece into this, making sure the guide is tight against the fence, and the workpiece is also. We should be ready to go.